Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 24 from the February-March 2023 IGCSE Cambridge paper 2 variant 2 from the 0580 extended syllabus. This question is about probability. It says the probability of Jamie hitting a target is 1/3. The probability that he hits the target for the first time on his nth attempt is 64/2187. So if the probability of him hitting the target is equal to 1/3, that means the probability of him missing the target is going to be 2/3. So either he hits it or he misses it. So the total probability is 1. So if the probability of him hitting the target is 1/3, the probability of him missing it is 2/3. Now it's talking about the nth attempt, and this is a probability. Now, for us to maybe be able to understand the question a bit better, what we can do is, if we think first about how this would work. So it says the probability that he hits the target for the first time on his nth attempt is this much. Let's change this question a little bit and say, let's find the probability that he hits the target for the first time on his 4th attempt, for example. Just work out what that probability is. On the 4th attempt, that he hits it on the 4th attempt, which means, that he hits the target for the first time on the 4th attempt. That means the first throw, the second throw, and the third throw, he's missed all of them. And then the 4th attempt, he's hit the target. So what would be the probability of this? Well, he would miss for the first throw, so that would be 2/3. Okay, then he's going to throw again, and the second throw is independent of the first one, so you multiply by 2/3 again. The third throw, multiply by 2/3 again. The 4th throw he hits, so the 4th throw is going to be 1/3. So that would be the probability of him missing, then missing again, then missing again, then hitting. That's how you'd set it up. And what you notice is, it's like 2/3 is multiplied by itself 3 times, and then you're multiplying by 1/3. Okay, so if we were to extend this, supposing it said the 8th attempt, then how would it look if it said the 8th attempt? Okay, you'd have basically him missed 7 times. Okay, and then the 8th time he would hit. So when it says 4, this is a 3. When it's the 8th attempt, then this is going to be a 7. And this is always going to be just 1/3, because when he hits it, right? So whatever number's here, this is one number less than that. Okay, because that's the number of times he misses, and then the very last throw he's going to hit. So if this was, for example, if the probability that he hits it on the 100th time, then this is going to be 99 and times a third. So it'll be 2/3 to the power of 99 times a third, for example. All right. So supposing they've given us this algebraic number n. Okay, so what did we do to the 8? Well, we took away 1. What did we do to 4? Well, it became 3. We took away 1. What did we do to the 100? Well, we took away 1. It became 99. So what do we do to the n? We take away 1. And then the last throw is when he hits the target. So it's going to be 2/3 to the power of n minus 1 times 1/3. That would give you the probability of him hitting the target for the first time on the nth attempt. And that is what's equal to 64/2187. Okay, so this is how we set up our answer, right? So it's always a good idea to put some real numbers in. So in your mind, you're thinking, how does this work, right? And then once you've put some real numbers in, you've worked out the procedure, and then you can just take what we've got there. That is now the equation that we have to solve. This is a exponential equation, in fact, right? So what I'm going to do first, I'll write this as 2/3 to the power of n minus 1. I'll get rid of this third. I'll multiply both sides by 3. So if I take 64 over 2187, 64 over 2187, and I multiply this by 3, that gives me 64 over 729. 64 over 729. So I can see here that this is going to be I can form some sort of exponential equation, where in this case I can make the bases the same, and then I can equate the powers. So let's think of a way of making the base is the same. So this is 2/3 to the power of n minus 1. Now I'm guessing that I can express these both as, like the 64, I can express it as 2 to the power of something, and the 3, I can express it as 3 to the power of something. And let's see, we know 2 to the power of 6 is equal to 64, right? If we raise 2 to the power of 6, that gives us 64, okay? So that means 3 to the power of something, and it should be 6 as well, will give us 729. Yes, it does. 3 to the power of 6 gives us 729. So I know that this is to the power of 6. 2/3 to the power of 6 is going to give us 64 over 729. Okay, so now once the bases are the same, I can say the powers must be equal. So n minus 1 is equal to 6. So n is equal to 6 plus 1, which is 7. So the value of n is 7. Okay, and we can check our answer is correct by putting it back into here. We can say 2/3 to the power of 6. Okay, so if we put it in here, that should give us this answer, just to make sure. So we have 2 over 3, close the bracket, to the power of 6 times 1 over 3. Now what does that give us? 64 over 2187. So we know that we're correct. All right, so n is equal to 7. Okay, because we had 7 minus 1 to get, that's why we got the 6 from. All right, so that's how we answer such a question as this, number 24. It's quite, it's not that, it's like involves indices, understanding how to solve exponential equations and trying to, set up this from this word problem, like from using probability. It's a bit more involved, but it's doable. Okay, it's not too bad. All right, so that's question number 24 from this paper, February, March 2023. Other questions from this paper can be found in the playlist that will appear in this region over here. Other questions from probability, you'll find them in the playlist over here. Other questions from indices and exponential equations, which I'll also include this in, the playlist will be over there for that. And you can watch the video that will appear in this region here to help you navigate my channel to find things you might want to find in a more efficient manner. Thank you for watching, and see you soon.